please. Okay, hello everyone. There's been a bit of a hiatus as I've been away in Europe, but we're back and we're doing a bunch of design reviews for version 15. So, first one is about error handling. So let's take a look at what we've got here.
All right, so Stephen, basically this is a continuation of the previous design review, and I sketched some kind of plan of what would be good to do today. So it's this bird's eye view. So we need to first of all refresh on how the basic things work, and then go through some naming of functions. Some functions you saw, but just briefly. And there is the error translation layer, which we only touched in August, but we have now the first sort of spec and implementation to show you.
Okay.
And that should hopefully complete the version 1 of this framework.
Okay.
Okay, so first of all, this is a brief refresher. So we have 3 main functions. And so one is to register this exception types. And I immediately want to point out that the name here is somewhat different, and I'll explain why. But the
Different from what
previously,
we discussed, or what?
yes, from what we discussed. What we
What
discussed
we discussed, yeah.
was a register exception type, which still works. Register exception type. But there
Okay.
is a good reason why we want to suggest to you to still rename this function.
Okay.
But uh, but before we do that, let me just remind you how all this works. So first of all, you register some type, which is failure tag exception type. And then once we do this, you can use this type to throw exception with this type. And this is a simple example of a function that in some cases
Yes.
throw this exception.
Yes, I get it.
Yeah. Now, in the case of abnormal execution, this function throws this exception.
Yes.
And then this exception can be caught by the other function, which we previously called handle exceptions, but we also have a suggestion to rename it to catch exceptions. But whichever name is, it catches this exception.
Yes.
Bless you.
I'm
Um,
I managed to get sick in the last 2 days of my trip, but anyway, at least it waited until the last 2 days. But go ahead.
okay. So the argument that catch exception takes is a pattern. It can be just any pattern, but we suggest to use failure pattern because it's more restrictive than just the underscore that catches everything, and we rarely want to catch everything. Typically, we want to only catch things that we throw.
Yeah, I understand.
Okay, so that was basically all. No, this is all known to you from the previous meetings. Um, the other
Yeah.
The other thing is that you can also use you can, for example, store, because it has an operator form, you can store it in a handler, and then you can apply this handler. And we also had a discussion that it would be good to have the holding subvalues, but because we don't yet have holding subvalues, we are returning a function that is hold first. Um, so, so this is the kind of refresher, but now,
I'm not happy with some aspects of this, but go ahead. But go
okay.
on. Show me the more realistic version.
Well, more realistic version is just a bit more details. It just shows you that you can define, in fact, several tags.
I have no freaking idea why you want to call this register failure tag. It just seems completely wrong.
Yeah,
I mean, this
I
is a
wanted,
family of exception handling objects. Why are we confusing everybody with failure, which is a thing, which is a symbol that has tags inside it?
yes, Steven, this is exactly what I wanted to explain. This was a result of several meetings, and this was basically the idea that Ricardo put forward, but we kind of agreed with that. Let us see if you agree with that or not. But the idea is this. The tags that we define, or types, they could serve 2 different purposes. One is essentially scoping, that you catch what you throw.
Yes.
And that would be restricted essentially usually to the package. So those symbols will usually live in the packages, and they will ensure that they're unique and you only
And
catch
how
what
does
you
it
throw.
relate to the new package format that hopefully we're reviewing very soon?
It will work with that. It doesn't. I mean, it's completely orthogonal. So it's in no way depends on any
Well, does it
things
play
that.
nice with it? I see where we have a design
Yes,
review of that in 3 hours.
yeah, yeah, absolutely. It plays nice with it because it basically it only takes the symbols with contexts. So as long as you have contexts, it's fine. So this is like a foundation that
Yeah,
you go ahead.
Go on.
Sorry, I thought
if
so.
anything, the new, I mean, this is a prime action outside of of
I'm sorry, what?
what I was saying is that the new package format has this layer that is the package scope. So this is not something that you want to make public to other packages, but it's also not something that you want to be private to a single
Well,
file.
I don't understand what
So
you're talking about. The main issue here, there's a
uh,
question of scoping exceptions. The scoping of
Right.
exceptions should be scoped by this package, by the, you know, package scoping as well, right?
Yeah, it will. So basically, the scoping of exceptions here is simply governed by the that you define this tag, and this tag belongs to it's a symbol that
I
belongs to
don't
some
like it.
context.
I don't like it. It's the same thing we have with throw and catch, and it was a disaster.
No, 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 it's completely different, Steven.
Why?
Uh, the reason is that in throw and catch, you have some arbitrary pattern as a second argument, and there wasn't a natural way to basically ensure that you will always catch what you throw. But in this system, it is because basically you define the error type somewhere, like for example here above, you define error type,
You're using
and
17 different names again. Failure
yeah,
tag, error type, exception
yes,
type. Come on, we can't do that.
right. I wanted to explain to you why we want these renamings. If you say it's not going to work, it's not going to work.
Well,
But
okay, the
I'm,
throw
I'm
exception,
I,
catch exceptions. That seems okay.
okay. So then the only kind of the only stumbling block currently is this name for this registering function. And let me,
Why do you need that registering function? What does it do?
well, that registering function basically creates the persistent notion of an error type that can be
But why do we
also
have to register it? Why don't we just have it? Why does it need to be registered? What good does it do anybody to register it?
uh, well, there are several reasons why, but basically um, uh, when you do that, you can provide certain properties and certain configurations that are essentially remembered by your system, by your package. Uh, and also, it tells it that it's something that exists rather than some completely arbitrary thing that basically, I mean, it distinguishes arbitrary symbols from the symbols that basically carry this semantics that they are error types.
The
Um,
What?
main reason is inheritance, right?
What are you talking
that
about? Okay,
the error
go on.
types that we register, they can also be inherited because you can you can register several of them. Like for example, in this case, there are two other types that are inheriting from the core one. And then because of that, you can throw specific errors, but then you can catch uh, the generic error that is the parent of them all. So the typical workflow is then that you define a single root error type for your project or your package, and then you define a bunch of subtypes. And in fact, for Tabular, for example, there are like already probably 30 or 40 subtypes for the main root error type. And Tabular is using this framework already. It has been using for a while. And then when you catch, you can just catch the parent type, and it will automatically catch the subtypes. So you can be very selective in what you're catching.
Very
And if you
unselected
do,
from what you're catching. I mean, you can be okay. Let's go through this again. Okay,
sure,
the main thing you
sure.
want to achieve is how do you define? So let's say you have a root error type.
Yeah,
Okay, and then you want to define sub errors of that root error type.
right.
Right? How do you do that?
By using this function,
No, no.
register
How
it,
do you do it specifically?
you
I'm
execute this
sorry,
code.
the fact that I've been gone for such a long time makes me probably more impatient than usual. Like, come on, guys, come on. Let's just okay.
Okay, okay.
How do you
So
do it? Show me how you do it.
you execute this function, and it
Yes, but
basically adds
where is it saying that it's a subtype? Where's the subtype specification?
here the second argument. You can
Okay, what's the
actually
first argument?
the first argument is the symbol that you want to designate as a new error type that you are defining.
Okay, so the second thing is its parent type. Is that correct?
Yeah, it can be
Can
more
you
than
show me the
one, but
documentation for this thing?
there isn't yet
Okay.
because
Why
we
do you want to
still,
call it failure rather than exception?
yeah, that's the core thing. Why do we want to do that? Because I mentioned first row, which is essentially scoping, but there is a second one. We may want to standardize errors, right? And we actually discussed it with you last time. We even went through some various types of how errors could be named and so on, like symbols that maybe probably will be in a system context, which will be generic standard errors for various things which are common. But the thing
How
is
does
that
this relate to the failure function? Failure has tags in it. What are these? What is the relationship between?
yeah, okay. So the relationship is that with this
This
new
design is
type,
too complicated. Go on, go on, go on, go on.
these new types basically become the tag of the failure, but the only difference with respect to the standard case is that first of all, they're symbols, and secondly, if there are types and subtypes, then they are automatically expanded, so your tag is not just the single type, but it's a full expansion of all the type with the parents. So there are technical reasons, but there are also conceptual reasons to do it this way. And then basically, this is the new type.
Conventionally, failure tags are strings.
Yes. So
So
one extension that we need, and we actually discussed it several times in these design meetings already, that one extension that we need of a standard failure object is that it accepts also lists of symbols as the tags, not just necessarily strings.
so you have modified failure in this package, or you need
It doesn't really need a modification except for probably the box, the formatting, because it's for this to work, we didn't have to change anything for the failure code.
okay.
It's just that this extension produces failures with the list of error tags, which are symbols. And it can't break any existing code because existing code only relies on the tags, which are strings. So these new failures are. But in any case, that's the whole point. That if we want to standardize the new types, which are symbolic types, then typically we don't, these standard types, we will not throw as exceptions. We will just return them as public failure objects. And so this is sort of a second.
Okay, let me ask a meta question.
Sure.
Have you guys looked through this without me? This seems unbelievably overcomplicated and a mess.
But Steven, we went through this with you 2 times and you approved this all.
No, I didn't.
It's just
not the concept of look, listen. Okay, give me some examples of actual, generic failure types and so on that you want to introduce.
Well, it was basically what we discussed with you, and I can open
Right,
this.
but can you be specific? Right?
Yeah,
So
like for example here.
Okay.
They are
So
called
what have you done
exception,
with
but
these? What have you done with these? Yes, and they should be called exception.
But if they're called exception, we have to throw them. We will not necessarily throw them. We can also return them. Because public functions, we don't allow yet public functions to throw things, and we probably never will.
Okay, so the issue that you have here, which is a mess, is that right now we have a mechanism where system functions can return symbolic failure objects. right?
Yeah. Yeah.
Okay. Now, you also have a mechanism introduced by you recently to great fanfare where you can throw exceptions instead of just returning things. The
That's
returning
right.
mechanism is what confirm and close deals with, correct?
Mm, not quite. Confirm and
No,
close
actually, it
essentially also
also,
throw.
okay.
Confirm and close, they also throw. It's just that they throw like lexical confirms, they throw locally. But non-lexical confirms, they do essentially the same thing. They throw globally.
Okay. Okay, so can I see some examples that actually use things like timeout exception?
Mm, we haven't introduced any of these yet into the system. We just were discussing what possible names of this could be. I could show you examples how exceptions are propagated in these. I have a bunch here in this notebook, but they are not with these standard types. And moreover, with these standard types, it is more likely that they will be returned rather than thrown, because typically you don't want to throw things that many things can throw, and then many projects, and then you don't know which function
Well,
throw
so what are
has
these
throw.
for?
These are for error types because, for example, there could be various specific error types, like for example, for URL requests. That was Ricardo's original example,
Yeah, okay.
and many other
But
things
I mean,
where,
look, if I have a user-defined function,
yeah,
I could perfectly well have a malformed or arguments exception, right?
yeah,
Perfectly reasonable thing. We could create a function that generates an arguments exception, right? For a
yeah,
user-defined function. Okay, so then how does that propagate?
yeah. That's the whole point. That if it's within your package, then it will propagate as an exception and probably will be caught on the outside by one of the catch exception statements. But if it's something that you return to the end user, then we don't really allow to throw an exception. We return things. So we will have to actually
Well,
return a
I'm
failure of
sorry,
this
that's not a
type.
good argument. I mean, right now, if you throw to top level, something comes out.
Yeah,
Partly an error message, but something still comes out, right?
yeah, yeah.
Something comes out. So the main loop catches something and converts it from just like a bubbling up exception being thrown to, it has a net that catches it.
That's yes, but that's not right. And I think it's like hold of the exception or something. But
Yep.
I don't but that I don't think is the point that Linnet is making. The point is that, if you call, plot, you expect it to return something, possibly a failure object. I mean, obviously it currently doesn't, but it could. But you wouldn't expect it to throw an exception that you would then have to catch in your own code just because you called plot. Or, maybe create file is a better example, right? If create file create,
Well, I would argue that things like create file, it would be nice to have some way of either a wrapper, an option, or something or other that says create file, and it's more like a confirm or something that says, if this didn't work, throw an exception.
Yeah,
well,
but Steven, the problem with this is that the whole language is like the code that people wrote in the whole language has been based on the idea that we can't throw exceptions to the top level. So everyone expects things to be returned.
Great. That's fine. But going forward, we could perfectly well have a file exception that does propagate to the top level. The fact that people have caught it in a different way before is not relevant.
It may be relevant because some of the functionality we have accept functions. So accept essentially user-defined code as arguments. And so they do not expect that code can throw something.
What?
And it's all throughout the system. So if we start
No,
doing
I don't
that,
understand. That doesn't make any sense. What are you saying? Throw will still work. It
sure,
will.
but imagine that you have a function taken as argument, like for example for the map, which returns something. And that was your argument, Stephen, about a year ago when we were discussing this. That if instead of returning that map, the function that is being mapped will accidentally throw, it will ruin the whole result of map, because instead of returning some list where something is just $fail or something, it will just not return anything. It will just throw an exception. And people do not really expect anything like that. So this will,
Right, when we decide, when we wanted, infinite recursion to throw an exception, you insisted that no, it has to sort of be auto-magically caught, which, has caused its own share of issues. So I am curious why. I'm certainly surprised by the fact that you seem to no longer care about the fact that, a function, right? If you're
Okay,
calling
this is
something
a mess,
function,
guys. This is a mess. I don't know
Steven,
where
but
we're
you
going with
accepted
it.
this design. We had 2 iterations where we had
Yes,
through
but now you started changing it and deciding that it needs to be generalized and putting in these, failure types, which I do not believe in. If this is an
No.
exception-based design,
But
it's an
Steven,
exception-based design.
let
We can
me,
deal with that. Don't try and merge it with something about failure objects, symbolic failure objects.
but Steven, I think that this naming change that originally Ricardo proposed is that if you ask yourself, what are these exceptions? Where do they live? They actually live in the same place as the failure tag. So that was the proposal, but we can drop the renaming and keep calling them exceptions. The thing is, probably people will be confused as to why they're called exceptions, where they quack like failure tags. They
Okay,
live in the
let's go
first
through this
argument
again.
of
Go back to
failure.
the top, please. Back to the top.
Sure.
There's nothing here about the name change that
You
wasn't
know
in
what?
the last
I
one
am
you saw.
I am feeling a repeat of our ridiculous database access stuff that is completely unusable. I'm feeling a repeat of that. I'm sorry.
But Steven,
I'm not happy here.
Steven, but Tabular and a bunch of like at least 2 other projects already use this framework, and it's
Yeah, but
very
they don't
usable.
use it with all these renamings.
We don't use these exception things.
What do
Yes.
you use, Rob? Can you be specific what you use?
Well, we use raise and handle, and
Which have been renamed. The
Yes.
throw exception and catch exceptions.
okay,
Yes.
so fine then.
So you
Yeah.
use those. Do you
So we
use
use-
this whole business about failure or exception types?
We do in a very limited way.
And how do you use it?
Well, we use we have an exception type of things as a tabular exception, and then so the tabular, the handle with tabular catches those types of exceptions.
Right, but that's exactly how they're supposed to be used. It's just that the only thing that Tabular doesn't use very extensively is more complicated tag hierarchies, because essentially it uses just the root plus the children hierarchy. But
Okay, so it has
still
explicit
uses
throw and catch, basically. And it would be ordinary throw and catch were it not for the fact that the thing that's being thrown is, show me again at the top, please. When you say throw exception, what do you have as the argument?
yeah. So when you use throw exception, the first argument is the type with which you throw, and the second can be any additional information that you may want to throw. So if you want to basically add something.
Is it a type or a tag? You call it tag in the failure object.
Well,
So
it is
throw
actually
exception, for some reason, when it goes to the top level, it is converted from an uncaught throw to a failure object, correct? It's like a great big enclose around the outside that's converting these things. Am I right?
Well, actually, it is being this failure object is being propagated through. It's just being caught. So if you just do catch exception of this, you'll get back.
I don't understand why I can't just say catch exceptions of that. I don't see why I need the blank. Get rid of the blank. Get rid of that blank thing. Just wrap it around the throw exception. Or does it not work? Well, tell me why it doesn't work. It doesn't work. You're telling me it doesn't work. This is a mess, guys.
No,
this
the first argument is a pattern that tells it which exceptions to catch. You don't always want to catch all of them.
I understand that.
And
you're
in most cases,
we can't hold subvalues.
And the operator form is the one that developers will use most often because you don't have to change your code.
I think it is a problem that we can't hold subvalues.
And well, I mean, we've made progress on that. Can we deliver that for 15? Maybe.
It is a problem, but technically we can so far still return a function that holds things. So
I mean,
we can
if we could deliver the hold all sub values and say in the week after the tech conference, could you use this for 15, or would it be a big invasive change?
We probably could, but also, I mean, in the case of catch exceptions, definitely. There are other cases where we have operator forms where it's doing a bit more than that because it kind of, in some cases, may want to compile and optimize things at the time when you do the definitions. So in those cases, it's questionable whether we should switch to that or not. But for catch exceptions, I think, yes, we can. But Steven, to repeat your question about underscore, why we need this argument, because we really don't want to catch everything. I mean, if you want to catch everything, you use underscore, but if you want to be more specific, which is most likely the case, you will use some kind of other pattern.
Is there a two-argument form, catch exceptions of the expa comma tag to catch?
Yes, there is.
Okay, so this is This is eliding the first argument. The one argument form elides the first argument, correct?
Yes, exactly. So you can also use this.
Okay.
Which
is similar to catch.
It is similar to catch, but the real difference is that when you do throw and catch, then your sort of a tag that you catching, it lives outside of your payload that you're propagating. But in this case, this failure that we propagate, it is completely self-contained. So it contains all the information about like the error identity, which are these tags that we expand inside. And so then when you catch, you don't have to separately provide some sort of patterns and whatnot. You know that this payload here, it contains all the information about the error, including its identity in terms of tags or types, which is the difference between throw and catch. And also it does it in a more controlled manner, because in throw and catch, it's based essentially the patterns can be anything, but here we are kind of suggesting you can still use underscore, but we suggest to use failure pattern, which allows you to be more restrictive and still reuse the type hierarchy. So you can use ABC, but you'll catch all the errors of ABC and all the subtypes of ABC.
This is really complicated.
Is failure pattern a real pattern? Like,
it's a real pattern, but it's the problem with it is that it has to evaluate. So it will not work inside something like a hold pattern, but otherwise it's a real pattern.
Except that it isn't.
Yeah, it's something that evaluates to a pattern, which is
it evaluates the pattern, yes.
Which is different from everything I believe that it's called foo pattern at the moment.
Yeah, so hold on. So the main functionality you want is the ability to say catch exceptions with a parent tag, basically, that will catch.
Yeah.
Yes, that's the main functionality. Is there any other functionality you're trying to achieve?
Well, yes, but it's a little more complicated in the sense that, for example, you can attach certain information to the types of tags. Like, for example, in tabular, the certain names of the messages are attached to them. And then in your error handling, you can extract that. So you can do significantly more sophisticated things with this than just catch the parent tag. For example, catch exceptions also accepts it accepts the clauses with the rules. Let me just show you. We were showing that last time, but right, for example, here, you can see that you can, depending on what is the specific error that you have, you can do different things with this error. So in this case, you just return it. In this case, you, for example, echo it. So yeah, so basically, this is already an improvement over cache and throw in a different direction, that you can create a much more sophisticated dispatch using the rules and idiomatic Wolfram language. So this is the second thing, but there is still more.
Okay, so the main point is that, oh God, this is such a mess. Okay, you're saying there is a thing called a failure pattern, which is a thing that is typically added as a tag inside a failure object. True statement or not?
Well, failure pattern is a pattern, yes, which represents a failure with this tag being one of the tags of this failure. So
I mean, it's very similar in idea to key value pattern, right?
Yeah, it is. So failure pattern, if you look at it, it basically is a failure object which contains this specific tag as one of the tags in the tag expansion of the first argument of the failure object. So it's a fairly simple concept. But because of that, because we expand this tag to contain also the parents, then just indicating this, you can catch both this error and the error of all subtypes of this error. So if I'm asking for failure pattern of ABC, this will match, this will also match the failure that is being thrown by the subtypes. For example, this guy. You see? So this one has been thrown for the subtype, which is ABC bad RX.
But what you're doing here is you're blowing up. I mean, basically failure in the past had a tag that was a string. Now you're saying, let's have a tag that's a symbol that we can somehow attach to this essentially symbol table. It's not like entity stores, for example, where you have entity stores that have names which are strings, right? You've decided that you're going to use symbols for these names for some reason, which I don't really know. And you're going to change the conventions for failure objects to use symbols there instead. Is that correct?
Yes, to use symbols or a list of symbols.
I mean, the main reason to use symbols is to be able to make them unique, right? If you have a string, then you cannot guarantee that nobody else in the known universe will use the same string, and then it would catch errors that were not intended for you.
Well, why do you think the symbol is unique? I mean, you can have something else with the same symbol.
They live in your package. They live in your package context, and nobody else uses that. They are scoped.
Right. I mean,
and normally not.
So somebody would have to be evil and deliberately use your private package.
Okay, so the main point is they're scoped as symbols.
Yes.
The package scoped as symbols.
Yes, Stephen, but there is another point as well. Because they expand with their parents, you can define hierarchies even if these are system symbols. And if you are not using them as exceptions, but just as failure tags, you can standardize hierarchical errors, which frequently happens in various domains. And this was the reason why we thought it might be good to do this renaming that started this conversation from the start, to begin with. That apart from being used as exceptions, we could also use these symbolic tags as a way to document hierarchical error causes, which we don't currently.
So we're going to basically say, when there were failure objects returned in the past that had string names, string tags, right? We've got a whole bunch of failure objects with string tags.
Yeah.
Like timeouts and things like this.
Right.
You propose that for version 15.1 or something, that all of those would change to symbol-based tags. Is that correct?
It depends on how we decide what we decide about it, because we do support string tags. You can still use them with this. For example, let me just show you an example. If I do, for example, catch exceptions, and then first of all, okay, if I do throw exception, and then you do even like a tag, my old string tag, tag. It will still do the right thing. It's just that the tag will be string. And then you can use catch exceptions to catch this. So for example, underscore or failure pattern. So it will work all right. It's just that, so if someone wants to still use these string tags, we'll let them. It's just that we recommend that in some cases, especially when you need to scope to some package, internals, you probably are better off throwing symbolic tags, but we do not necessarily require that. And for string tags, we don't have tag hierarchies and we don't have this parent-child relationship.
Yeah,
But otherwise, you can use it.
There's a problem with the symbolic tags, and we worked, I think Carlo actually wrote the workaround for this in Tabular, is that, when you use symbolic tags that are in your context, well, that's what shows up for people when they see the failure object. So we actually retranslated all our failure objects in Tabular back to string tags for output to top level.
Right. But if we look at all the projects which are large enough, they have this translation layer. And in fact, I have one of the things that I wanted to discuss today is exactly this error translation layer that actually automates that thing, where essentially, let me just quickly show you how it looks. It boils down to defining this sort of rules for error translation, which convert the internal errors to the public errors that you give to the user. And in fact, most large projects I know about which use exceptions, they have some sort of this error translation layer anyway. So I think the existence of this error translation layer is just the reason for that is that we can't throw things and we have to always convert to something that we return. That's the same problem as we discussed before. But returning back to this, string tags are still supported by this framework. So depending on how we want to go with this, your question, Steven, your question about string tags for some errors, we can keep them as they are, or we can replace them with symbols. It depends on how we decide about it.
Well, okay, what is the minimal thing we could introduce into version 15?
Okay.
I don't think this design is right. Okay, I'm going to say that I don't think it's right. I think it's a mess. I think this thing about having, whenever we've had one of these things that says declare a thing, pretty much all of those things are a mess. The fact that this declaration looks, go ahead.
Yeah, I mean, the fact is that the current internal version of these error tools, right, which have been used in several projects, and I'm using it in my current new project, all already have this functionality just with a different name. And that is what developers need for error handling, because error handling with exceptions internally is a lot more convenient than having to test return values of functions and
I
say
agree.
if failure.
I agree.
And,
okay.
So
why are we mixing these things? Well, go ahead.
Yes, and on the top level, you need to still return these old-fashioned error messages. And so if we don't provide a version of error tools that satisfies the needs of the developers, people will just continue to use their own
I understand, but you're muddling a lot of things up, right? You're saying there's a current thing with failure objects that involves symbolic returns that you test. Okay, then you're saying this is a new exception-based mechanism. Fine, I'm okay with that.
No, the exception mechanism is not new. I mean, we are using that. We have been using that for a couple of years now.
No, I understand internally, but it's newly exposed to users.
Yes.
Right? Okay. So that's what's going on there. So now you say, but look, if it did return to top level, what would it actually return? Because throw returns some rather indecorous mess when it's uncaught, right?
Yes. I mean, we are not proposing to return or to have uncaught throws.
Why aren't we just having look, like terminated evaluation, a bunch of these other things? Why aren't we just having an uncaught exception symbolic wrapper that is the thing that comes out at the top level in the main loop if you have an uncaught exception?
Yeah, this is one of the
as a standard way of doing things, or as a beautification of something that went wrong, like
yes, it's a beautification of something went wrong. right?
Yeah, I mean
It's-
that could easily be done. I think Leonid
right,
already
but
has
I
an
don't
idea for
think you
that,
want to
right?
mix up. Okay, look, we've got a whole failure object thing, right? Which people have been using for decades. Okay, it
Well,
involves,
not
as you say,
decades.
what's that?
Maybe a decade, certainly not
Fine,
decades.
fine. And confirm, for example, transitions from the failure world to the exception world. Right? If it sees a failure, it generates an exception. Am I right?
Not necessarily,
It
right?
generates a throw, basically. Right?
Yes.
Well,
Okay. So now what I think I'm saying is do not muddle up the failure world of symbolic returns with the exception world of essentially throws, dynamic
Right,
throws.
Stephen, but that's exactly what we're trying not to do.
Okay, but you know what? By the time you have failure pattern tag, you've lost the game. That cannot be the thing you use for exceptions. It cannot be. That's a different world, and you should leave it as a different world.
Stephen, what we tried to explain is that those two worlds might not necessarily be that different because what we started was reusing failure as a container for exceptions. True. But then there is another aspect of this, which is all the failure objects that we are returning for all this decade that we used failures, they have somewhat ad hoc tags with their, the names.
Yes.
And we thought that now that we have this hierarchy of tags, that those hierarchies could be reused more widely than just for exceptions.
I understand your claim. I think you're wrong. Okay, so here's the deal, right? First of all, have you inventoried every single place in the system that uses a failure object in the
No.
built-in code? Okay, I think you should do that. Because I think what you're going to find is there are a large number of special cases where the failure object that's returned has some tag that makes sense. Currency didn't exist at that time when you're trying to do a currency conversion to euros in 1207 AD or something, right? That's it's useful to have a tag that says currency didn't exist then, rather than just saying, oh, let's try and shoehorn it into some other completely different thing, like, data unavailable or something like this.
Sure.
You know what I'm saying?
But the thing that we suggest does not preclude those uses.
Yes, but you can't have both. You can't have both. Either people are going to have these somewhat arbitrary failure objects, or you're going to have a very structured setup which you have not developed far enough to know whether it will work. Right? These exception types that we discussed before, I think what we should be doing is making system functions have a wrapper that causes them to generate exceptions when they fail. Do you understand what I'm saying?
Yes, but
I
those wrappers typically they will not work, Steven, in at least if I understand you correctly, because it has to be a decision of the developer, not of some outside code.
No. You're not understanding me. Over the next some number of years, the idea would be to make exception hooks into a whole bunch of system functions. Do you understand what I'm saying? So if there is a file error, wait a minute, if there's a file error, instead of you just getting a failure object you then have to test, the thing would actually generate an exception. See what I'm saying?
You suggest this exception to propagate bubble up to the top level?
Yes, I suggest it to be handled like other exceptions, as an exception mechanism, not as something which is halfway a failure object and halfway an exception. I think it has to be, look, most of the time, most people doing interactive work are not going to use exceptions. That's something people are going to use if they're making serious programs, just like they're going to use the package format if they're making serious programs. Nobody wants to use packages and contexts and so on if they're doing interactive stuff. It's just annoying to have things in the wrong context and so on. Am I making sense?
Sure.
So this is
but
handling...
I mean, this whole proposal is for those serious users.
I know that. So they're not going to use failure objects. That is for the
But they are using exceptions. They're just right. The thing they're throwing are failure objects.
no.
Yeah,
I'm
I mean,
saying I think that's a muddle. Here's what should happen. Over the next
Why?
few years, we should have a mechanism to take so that open read, for example, can, instead of just generating a failure object and maybe a message if the file doesn't exist, can have perhaps a headdress, perhaps something else that says,
Right, but
what,
this doesn't address the needs of the package developer who their own function fails, right? They still need to have some mechanism to throw something that can be
absolutely exceptions. They're what we're doing,
uh,
not failure
Stephen,
objects.
but
l-
but
let,
there
let,
well, but there's but I don't know what you mean by throwing an exception, right? Right.
I
I
think it's
mean,
what we're talking about.
ultimately it's a throw of some expression.
Yes, that's right.
Right. And the expression that's being thrown is a failure object.
I
So
don't think that's the right thing.
well,
what should be thrown?
Maybe a thing called exception object.
you know what
I think
is
that's a
interesting,
total
Stephen?
muddle to have the throw contain a failure object, a total muddle.
You know what is interesting? When we were discussing this with the error handling working group, including Christopher and Connor at the time, about 2 years ago, we were seriously considering using exception object. But then we decided that we don't want to multiply things like we tried to apply a common
Yes.
razor principle.
Yes, but it's
And
wrong in this case.
well,
It's wrong. We've got two different mechanisms. One is you return a symbolic failure object and you test for it. Period. End of story. Second thing is a dynamic thing that's based on throwing, that is, that's about exceptions. They're not the same mechanism.
they're not. It's not the
That's
same
true. I
mechanism,
mean,
but
right, you have right. I mean, confirm and close. Are you saying that confirm and close is a failure, right? It can test for failure objects and throw exceptions.
Yes, I know. I
For
was saying before.
messages, it can test for messages and throw exceptions.
Right. So it converts from the failure world, symbolic failure world, to the throw world, if I'm not mistaken, right?
yes, but
Well, for one of the things it can convert from, right? It can also convert from messages to exceptions and
Yes, I
right.
understand, but it is basically generating exceptions from examining this, both the symbolic structure and maybe the message generation capability.
Right. And the thing it throws is a failure expression, if I'm not mistaken. Or maybe that's maybe that's what enclose confirm it converts to a failure object. I don't remember what
I don't
exactly.
know what it throws internally. I doubt anybody sees that.
yeah, it converts when you have an enclose. At that point, you create the failure object that kind of catches what was thrown.
All right. I want to go back to what it is we want to achieve overall. Okay.
Okay.
Thing number one, we're trying to get exceptions that are a more controlled form of throw and catch. Okay. In particular,
yes,
we would like to have hierarchical, we would like to catch to be able to hierarchically reference, subcases of exception types. Okay.
yes,
So one approach to that would be to say, I don't know if this is the right approach, but I mean, what you're then saying is we're going to have a type hierarchy defined implicitly by a bunch of register exception type expressions. Is that correct?
yes.
I think it's a horrible mechanism. I mean, it's exactly what we always avoid, is something where there's some kind of weird hidden state. How do I see the graph of exception types?
You called exception types, and then well, in this case, there aren't many, but then you can do, I believe this should work, all common graph. Well, it has to be improved, obviously. It's just sort of something to start with. but it shows why there are three, because it also shows some internal exceptions that are used by the ErrorTools itself. But if we define more, then they will be all shown. Or you can just do exception types, and it shows you all the currently registered types. So this is one of the functions that we wanted to introduce as well, but we didn't come to that yet because of this discussion.
Okay, but notice what it's doing here. Each one is basically a tree of exception types. Is that correct?
Yeah. Yeah.
So why the hell do we need all of this stuff? Why don't we just have something where you can specify, so what you're saying is there's a type. If you give a type, somehow it's assembling the hierarchy of these types, and it's doing it one piece at a time by assignments.
Yes.
What is that function
Because typically,
called?
the reason why this is so is that it's very useful for people to introduce these things closer to the functions where they're going to use them. It's just a very practical thing that instead of writing them all as a single thing somewhere at the top of the package, whenever you want to throw a new exception of a new type, you simply register another exception type closer to the function where it's being used.
Okay, so let's go back to register exception type.
Sure.
Okay, which is the name it should have. We should not try and muddle up failure objects, which are symbolic expressions, with exceptions, which are things that are thrown, that kind of break through the evaluation hierarchy.
Okay, here it is.
Okay.
Yeah.
Okay, so ABC is the parent type. Is that correct?
Yes.
Why is it on a list?
Because it could be more than one, but in this case, you don't need a list.
Because it's some kind of multiple inheritance thing? Or
yeah, there might be. I have an example down below where it's kind of useful.
Okay.
But yeah, in most cases, there will be a single type, but in some cases, there can be more than one.
Okay. So exception types will give a list of all registered exception types.
Yes.
With no hierarchy.
No, unless like if you do exception type of ABC, for example, it will tell you only the parts. Well, there is only ABC currently, but I'm just looking whether I can define more types. I have them in examples.
No, let's not worry about that. We're running out
Okay.
of time. So can we scan through a few more things here, and then we're going to have to do another meeting.
Great. Okay, so Stephen, basically, we want also, well, it has to be called then exception types, not failure tags.
Absolutely. The only
exception types. Exception types. Okay. Then the other thing is failure tag queue, but again, it should probably be called then exception type queue instead.
I don't know why you're even doing that. I mean, there's a million other things you could do in the management of this sort of secondary symbol table.
Okay, so
I don't know
basically,
whether that's the most important function.
It is important because it checks whether something is just a symbol or something that is actually the exception type first, and second, it can have a second optional argument which checks for subtyping. So if you have two arguments, then it checks that certain type is actually a subtype of some other type, and this might be really useful. And then failure pattern, which if you don't like the name failure in it, we could probably rename. We could rename it to exception pattern then.
What does it do?
How about that? Oh, well, exceptional failure pattern currently, it basically just allows you to catch certain specific types. So it restricts what you can catch. And in particular, if
why
you
does
put
it need to be there? Why doesn't catch exceptions? The first argument of catch, I thought it was a second argument actually, but this is a sub-value case. The second argument of catch exceptions is the types of exceptions that it should be catching, correct?
No, it's more like the failure because you can then destructure it and do something with it using rules. It's not about the types. It's about the failure that you are propagating, because then you can destructure it.
Well,
If
I
it would
understand
be
that, but what are you talking about?
Yes,
I
I
don't
mean
understand. Why
the
isn't the
first.
left-hand side just a symbol?
Because what we are catching is we want to be able to destructure the failure, not just the type. You can use types separately inside failure pattern like this, and then you can catch both like specific tag and the failure. But what we wanted is that you can do anything with this failure that you want, because it's infinitely more useful.
Well, it's not a failure,
You
it's an
catch,
exception pattern.
it's an exception, but the payload that you're catching is a failure object.
No, it isn't. It shouldn't be. We should not be using failure objects for this. This is a different world. Don't confuse it.
So you suggest to use exception object, which is
I
going to be a
do.
new thing.
Yes, I do.
Can be done.
Okay, but then I don't know why we need, exception pattern. Why is that different from exception object itself?
Well,
This was a really bad idea to try and unify
no.
failure
I
with,
mean,
with
the
exceptions. Really
first
bad idea.
reason is the matching of subtypes, for which we do not have any language in our existing pattern world. And the second is that you can, of course, match not only on the tag, but also on the rest of the payload. So you can have an arbitrary pattern there. And so just like a key value pattern, which is tailor-made pattern for associations, this is a pattern that is useful to match specific exception types.
Okay.
Right. So basically, what we wanted to achieve here is that you can match on the sort of identity of the error, which is a type, but you could also match on something more. For example, this was Roman's suggestion from working on Wolfram Compute Services code base, that here we could just use some additional constraints that this exception is only caught not just when the type matches, but also when it contains certain things inside its information part, which is the
What do you mean, its
association.
information part? Why would it have an association in it at all? Oh, the
Because it carries
exception
extra.
object could. Yeah, the
Yeah,
exception object can have that.
Yeah, I mean, at the
right.
moment, failure patterns have a second argument, which is an association. And so if we now have exception objects, then we can decide what
Right, but failure pattern is not used
structure
anywhere
should
else,
be.
right? This is a new suggestion for this stuff, right?
Yes, failure
well-
pattern isn't even in the prototype build, so
Yeah, so it's a new thing. Okay. Okay.
Yeah, but again, if you dislike using failures for propagating
I do.
exceptions,
Let's not use failure objects. Look, listen.
Okay.
Nobody will ever understand this. Okay. We've got an exception system. It works with exceptions. We've got this system for dealing with symbolic failure objects. It works with symbolic objects. They are different worlds. Let's not try and muddle it up.
right. I mean, ironically, about 2 years ago, Stephen, I came with the idea of using exception object, but I lost it to the majority votes of the others to use failure objects. So,
Yeah. Well,
so
now
we
that
are
we've got it more worked out, it's clear that that's just not going to work. And I think also, I just want to come back to the system function thing, okay? Because I don't think you guys were listening, right? What I'm saying,
we're listening. We're just not agreeing.
okay, what I'm saying is there should be a mechanism to turn what would usually be a message and a failure return into an exception for a system function.
But isn't that just confirm? Isn't that just confirm?
Maybe it is. Maybe it is. Maybe it could be used.
If
that
I
way.
want,
don't know.
I mean, I don't think we want to change our language so that system functions are suddenly throwing things uncaught, that I have to wrap handle exception around my.
Oh, so how does confirm interact with catch exceptions?
Yeah. So,
there is a system function already that's called system exception, right? You guys know that.
That's a different thing.
Yeah, that's a different thing.
That's a very different thing.
I mean,
So basically, the way it currently works is that confirm, like, okay, here what I did, I registered exception types, right? Like one and then the subtype.
Yes.
And then when you use confirm with this type, then it basically does almost exactly the same thing as normal confirm does. But it adds the internal payload, which tells you more details about the propagation vehicle, like exception propagation vehicle, because it now uses under the hood the catch exception. The catch exception slash throw
I'm completely
exception.
confused. I'm completely confused. If I have a file operation,
Yeah.
okay, that would return a failure object or a message or whatever in its
Yeah.
normal evaluation.
Yeah.
If I then put a confirm around it,
Yeah.
and now I put catch exceptions around that, will it work or will it not work?
It will, in case if for your confirms you are using one of the tags that catch exception knows about.
Okay, so my
let me show
question is
you.
this. Yeah, but my question is this, that you've defined a bunch of tags that would be potential tags for system functions, like file error, right?
Yeah. Except, Steven, except for those tags, there still is this biggest question that we need to understand. Are we allowed to propagate exceptions to the top level for such functions? Are we allowed to have uncaught exceptions for public functions?
I don't understand what you're saying. I mean, I'm saying what Todd was saying is the only way you convert from a failure object return to an exception thing is by saying confirm around the function that could return a failure object, right?
Yeah,
It's the shortest way, yes. It's not the only way, but
Yes,
it's the
but I mean,
easiest way.
Okay, I could say if blah blah blah, throw exception blah blah blah, right?
Yeah,
Okay,
yeah,
that sounds
yeah.
interesting.
yes,
Okay.
but I mean, if I want to use this way of programming, I don't want to wrap confirm around every function call I do. There must be some other way to say inside this piece of code, please throw exceptions and don't return
Yeah, well, right.
failures.
That's what I keep on saying. I think it's a lot of work, but I think it's something that we should consider doing to take our system functions and have them have a way of acting in which their error conditions are exceptions. Do you see what I'm saying?
I see what
Right,
you're
but
saying. I just don't agree.
the real question, Steven, to me at least, is when you convert it to exception, who propagates that and for which purposes?
I don't understand. Look, for example, I could make 1/0 be an exception. Right now, 1/0 is just a thing that prints a message and goes on its merry way, right? Returns a
Yeah, but
symbolic
then now
thing.
you are into a world where basically every function can throw, and you have no idea on how in which one can do
That's
that.
why
Right?
we have these
That's
named types of exceptions. That's the whole point.
yeah, but the problem when what are you gonna do? Like look at the documentation. I mean, you wrote a piece of code and everything works, and then at some point the function starts throwing.
Yeah.
And this is not something that the function itself is telling you.
No, I
that it can
understand that, but this
fail
is the whole
in that
point. We've
way,
been through
etc.,
this at
etc.
great length.
Yeah.
Error
I mean,
handling is a secondary code path. The question is, can we make the secondary code path do something as sensible as possible, given that you're not putting a lot of effort into the secondary code path? See what I'm saying?
Right. But I mean, I think still one of the main questions is that previously, like if you look at how it was used previously in different projects before our effort here, we were always catching all exceptions on the kind of outer end. So public functions were never allowed to to bubble up exceptions to the top level. And the reason for that was that a bunch of other functions existing in the language were not expecting exceptions. So all the code base was not expecting that things could throw.
I know, but the whole point is that it will go, if you do a throw, the code base will be irrelevant because it's just going to top level. It's not going to be the other functions. If you say f of this thing that generates an exception, it's not going to see that exception. It's just that exception is going to cause it to go to top level, isn't it?
It is, but it's a radical change, and you were the first person to be against it previously.
Well, we have an existing example of that, which you've complained about at various points, Stephen. It's not an ideal design, but I think it matches the design you're talking about. And that if you make a sparse array of, say, with one rule, one instance, and say dimensions 10 to the 6 by 10 to the 6, and then you do normal on that, it returns this thing called a system exception.
Yeah.
Right. And let me point out that when we introduced recursion limit and it or sorry,
Terminated evaluation.
terminated evaluation, right? Basically, everybody except you wanted that to just propagate to top level, and you complained that it was killing your map and that it should
Yeah.
be auto-magically caught.
Yep.
And I'm very confused by why you are now arguing the
Because
exact
you're
opposite.
saying that there are two, we've been through this many times before. There are two styles of programming, at least. One where you're trying to make sure that nothing could possibly go wrong, that there was no possibility of anything, any error occurring anywhere because you've got some code, critical code. The other is I'm doing kind of researchy type stuff. I just want to keep going. Even though something goes wrong, 1/0s, whatever, I don't really care. If there's 5 1/0s, but there's 10,000 not 1/0s, I'm a happy person. See what I'm saying? The two different cases. One case is the one in which you want to be very sure nothing went wrong. If anything went wrong, just quit. Right? And the other case is damn the
Well-
torpedoes, just keep running.
Right. Well, isn't that confirmed quiet?
No, it's not. It's what we have right now with the whole
No,
failure
but
mechanism and so on.
no, but you said, the mode where nothing went wrong. Why is that not confirmed quiet?
It's not the same thing at all. It's just, look, there's a case where you want a
Why?
hair trigger. You want it to be the case that as soon as something goes wrong, the whole computation is aborted.
Right. And confirmed quiet does that. The moment there's a message, it terminates it.
Well, okay, fair enough.
All right. So Steven, this case corresponds to exceptions propagating to the top level, right?
Yeah. Which case?
The case when nothing can go wrong, and then if something goes wrong, we just quit. Essentially, this is what this is exception propagating to the top level.
Yes.
Yes. And then there is another case when you can't afford that because for whatever reason you expect, for example, partial results to survive or something else.
Yes.
But the real problem, I think, is that it's hard to draw a clear line between these cases.
Okay.
Because if some code never expected exceptions to happen, it will not suddenly, it will,
All right, listen, we have to cut off here because we're 13 minutes late for another meeting.
Can
Let's
I
continue
suggest
this.
something, Steven? I'm sorry. Can I suggest that next time we just get Christopher on board and get a kind of
Yes,
fresh
I don't know why
start?
he wasn't invited. I mean, it's completely crazy. You guys messed up. Okay, let's make that happen. Let's try and get a meeting in the next few days so that we haven't all forgotten what was going on, and let's try and see whether we can make progress on this.
Okay. Thanks.
Okay. Okay. See you guys soon.